Hello everybody! Today we are going to be multiplying fractions. So, when multiplying fractions, in order to multiply fractions and mixed numbers, each number must be written as a proper or improper fraction. Mixed numbers must be converted to improper fractions, and whole numbers must be written over 1. So, if you have a whole number here of 3, you might remember that I'm going to write this fraction over 1. Sorry about that. So if I have the whole number 3, I'm going to put it over 1. Okay? So step 1 for multiplying fractions is to change each mixed number to an improper fraction. So if you have a mixed number, it needs to become an improper fraction. Step 2 is multiply the numerators. Step 4 is multiply the denominators. And 4 is simplify. So I'm going to move on down to the first example here. So when we're multiplying fractions, these are already proper fractions. This is not a mixed number, so I don't have to do step 1. There is no converting. These are already in the right way. These are already regular fractions. So I'm going to multiply the numerators. So we got 2 times 4, which is 8. And then we have 3 times 5, which is 15. So your job is going to be to complete this problem right here. Moving down to the middle part, we have cancel common factors. So when we're canceling common factors, it's a way to simplify our answer beforehand. So what I want to do is find common factors that are across from each other. So the numerator from my first fraction and the denominator from my second fraction, I'm going to list the factors of each of those numbers and find the greatest common factor. So factors for 2 are 1 and 2. It's a prime number, so it is 1 and itself, 2. And we have 4. The factors are 1, 2, and 4. And our greatest common factor between 2 and 4 is 2. So the thing that I can do is rewrite both of these fractions using that information. So I take the greatest common factor and I divide it by 2. So I'm going to have 2 divided by 2, which is going to give me 1. And then I can take 2 divided by 4, and that's going to give me 2. Now for the red, I'm going to do very much the similar same thing. And these are the same numbers, so that's pretty easy. So the greatest common factor between 3 and 3 is 3. So I can divide both the numerator and the numerator and the denominator by 3. And I'm going to have 1 as my new denominator from my first fraction, because I did 3 divided by 3 here. And then when I do 3 divided by 3 here, I'm also going to have 1. Now I have a whole new set of fractions. So now all I have to do is multiply, and I'm going to get an answer of 1 times 1, because I'm going to be multiplying straight across. So I'm going to have 1, and then 1 times 2 is 2, And so my answer is going to be 1/2. All right, so quick recap. I want to cross reduce by finding the greatest common factors between the numbers that are across from each other from the first and second fraction. So I can take those numbers and cross reduce by finding the greatest common factor and dividing the greatest common factor by each, the numerator and the denominator. So 2 divided by 2 was 1. 2 divided by 4 was 2. 3 divided by 3 was 1, and 3 divided by 3 was 1. Notice that I put them in red there to show you that when you are dividing, that the answer for this first denominator in the first fraction when dividing by the greatest common factor will be 1. And that's the same for all of them. So you're going to go ahead and do your best to try to cross reduce right here on the next example and cancel common factors. So now we're going to be multiplying mixed numbers. So when multiplying mixed numbers, the easy way to do this is to multiply the denominator by the whole number and add the numerator. So we're multiplying the denominator by the whole number and adding the numerator. So 2 times 2 plus 1 is going to give me my brand new numerator for an improper fraction. Because remember, from the top, the first step, if we do have a mixed number, is each mixed number needs to be an improper fraction. That's my first step. So here's an example of that right here. So what I have here is 2 times 2 plus 1, which is 5. So now I have a brand new numerator of 5. Now the same thing is going to happen here. So I'm going to multiply my denominator by my whole number, which is going to be 5 times 3. And then I'm going to add my answer, or product, to the numerator. So I'm going to have a math problem that looks something like this. So I'm going to have 3 times 5 plus 3. So 3 times 5 is 15, plus 3 is 18. So I'm going to have a brand new numerator for my second fraction of 18. And now I can multiply straight across. So I'm going to have 5 times 18, which is 90. And then I'm going to have 2 times 5, which is 10. Now this is actually an improper fraction. So I can go ahead and convert this improper fraction by dividing the numerator by the denominator. So I want to know how many tenths are in 90. So I can take my numerator and divide it by my denominator. So when I do that, I can have 90 divided by 10, which is going to give me the whole number of 9. So this improper fraction actually converts to a whole number, which is really convenient. Sometimes it doesn't do that, and we have leftovers, and any of those leftovers end up being our numerator. So my real answer here, when multiplying these fractions together, is 9. So you're going to go ahead and do that example right there. All right, going down to the bottom of the page, We have two spinners here. So it says use your pencil or a paper clip to spin each spinner, then add, subtract, or multiply depending on each problem. So, using your spinner, you can spin your paper clip or whatever you have, and whatever number you're landing on will be your spin 1. So, if I landed on 2 and 1/9, I can put 2 and 1/9 from my first spin right there. So, for my second spin, I'm going to use the other wheel, and I'm going to spin my fraction. And I'm going to land on 1 2/3. So for spin 2, I have 1 2/3. So you're going to move vertically up and down to do this. So I have mixed numbers here, and I'm going to be multiplying. So this is the operation I'm using. On the top, you could add the fractions together. You're going to multiply the fractions together, and you're going to subtract the fractions and then multiply. So I am multiplying mixed numbers, and of course the first step when multiplying mixed numbers is to convert them to improper fractions. So I'm going to multiply 9 times the whole number 2 plus the numerator 1, and I get a new numerator of 19, and my denominator stays the same as 9. So remember, when you're converting mixed numbers to improper fractions, your improper fraction has the same denominator as your mixed number. On my second mixed number, I take 3 times 1 plus 2, and I get a brand new numerator of 5. Now I have my second step, which is to multiply the numerators. So we have 19 times 5, and gives me 95. And then I have 9 times 3, which is going to give me 27. Now this is an improper fraction, and that's okay. But if I want to take this improper fraction and convert it to a mixed number, what I can do is find out how many 27s are in 29. So what I can do is take 95 divided by 27. And here's how I do it. I like to do it with a calculator. So I can take 95 divided by 27. And I'm going to get a whole number of 3. Now, all I want to do is look at the place before the decimal. So I know that if I want to convert this improper fraction to a mixed number, and I divide, because I want to find out how many 27s can fit into 95, I'm going to have a whole number of 3. Now what I have is leftovers. So I need to know how many leftovers I have. So I need to know how many times 27, or what the product was of 3 and 27. So what I'll do is I'll multiply 3 times 27 to see how close I got to 95, just to see how many leftovers there were. So I'm going to take my whole number of 3 and multiply it by 27, and I see I have 81. So if I had another 27, for example, there would be 108. That's way too many. I went over 95. So I take the product of 3 and 27, and I get 81. So I can count on to see how many I have left over, or I can simply just subtract 95, take away 81, and that's going to give me my new numerator of 14. Now remember, your denominator stays the same. So there you go. I'm going to have a brand new fraction of 14 over 27 with the mixed number That's 3 and 14/27. And you can show your solution right there. So whatever you wrote right here can come on down. And just rewrite your answer down by the solution. So your answer is clear to see. Alright, so when I go on down to the bottom, we have a little word problem here. It says, a fruitcake recipe calls for 2 1/3 cups of almonds, which is a type of nut, and, which means I'm going to be adding 1 3/4 cups of pecans. So this fruitcake recipe has 2 1/3 cups of almonds and 1 3/4 cups of nuts. If Eliza would like to make 4 fruitcakes, then how many cups of nuts does she need? Well, I know that the amount of nuts needs to be added together to see what the total amount of nuts are being used in this recipe. So what you're going to do is you're going to add these mixed numbers together. And if you don't remember how to do that, just refer back to the previous video and your previous handout. Now once I get the total amount of nuts, I'm going to multiply that by 4 because she wants to make 4 of those fruitcakes. And then you're going to have your product, or really the total amount of nuts it needs to make 4 fruitcakes. So just a quick recap. I do have a couple videos to show you, and I'm showing you at the end here. So one of the videos here that I wanted to show you was mixed numbers and cross reducing. So I'm going to go to the cross reducing video here just to show you this process one more time and how it was done.
When multiplying two fractions together, it is possible just to take the numerators and multiply those together to get your numerator. In this case, 9 times 5 is 45, and then multiply your denominators together to get your denominator, and 10 times 12 is 120, and then you can take that resulting fraction and reduce to lowest terms. However, you will oftentimes end up with a fraction that is very difficult for many people to reduce. So what we are going to do is we are going to reduce the problem itself so the answer we get is already in lowest terms. To achieve this, we are going to use cancellation. To use cancellation, you must first identify one numerator in your problem and one denominator that share a common factor. For example, 9 is a numerator and 12 is a denominator, and they each share the common factor of 3. What you do is you cross out each one of those numbers and then you change it to however many times the common factor fits inside each number. For example, 3 can be divided into 9 3 times, and 3 can be divided into 12 4 times. You can kind of visualize 9 over 12 as if it were its own fraction and reduce 9/12 to lowest terms, which is 3/4. But we can do the same thing with 5/10. We can visualize 5 over 10 as being the fraction 1/2. And the reason we would reduce 5 over 10 to 1/2 is because they both share the common factor of 5. 5 can be divided into itself once, and 5 can be divided into 10 twice. The last thing we do is we multiply our remaining numerators together to get our numerator, and 3 times 1 is 3, and then multiply our remaining denominators, and the product of 2 and 4 is 8. So we would say that 9/10 multiplied by 5/12 is equal to 3/8. Let's try another example. This time we are multiplying 5/12 by 8/15. Remember, when using cancellation, you are only allowed to use one numerator with one denominator at a time. Sometimes people try to cancel with two denominators. For example, with 12 and 15, they would see that 3 goes into both of these numbers, but you cannot cancel out a 3 out of 2 denominators. It has to be one numerator and one denominator. So 5 and 15 share a common factor of 5, so we can reduce the fraction 5 over 15 to 1/3, because 5 goes into 5 once, 5 fits into 15 exactly 3 times. And we can also reduce the fraction 8/12. 4 is the common factor of 8 and 12, and 4 can go into 8 twice, and 4 can be divided into 12 3 times. Last, we multiply our remaining numerators, and that would give us 2, and the 2 denominators at the bottom of 3 would give us a product of 9. So 5/12 multiplied by 8/15 is equal to 2 9ths.
Alright, I have another video here for you. It is on mixed numbers, which is something that we did down here, and it's just going to give you a little bit more info about mixed numbers.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about mixed numbers and how they relate to improper fractions. Mixed numbers. I love mixed numbers. So full of protein and vitamins. You want some? Those are mixed nuts, and no thanks. I'm trying to explain mixed numbers. Oh, mixed numbers. You mean like when I get a whole bunch of numbers and put them in a bag and shake it up, pull out one to see who wins? You want to play? That's a raffle, and that's not what mathematicians mean when they say mixed numbers. Well, you sure are hard to please today. As I was saying, we're going to learn how mixed numbers relate to improper fractions. But first, we need to make sure that you understand what an improper fraction really is. To do that, let's start with a short number line that counts whole numbers from 0 to 3. And let's subdivide the spaces in between each whole number into 4 equal parts, or fourths. So a block this size represents the amount 1, because it covers the distance from 0 to 1. While a block this size represents the fractional amount 1/4, because it only covers the distance from 0 to the first subdivision that we made, which is 1 out of 4, or 1/4. But suppose we add another fourth to the fourth we already have. That would give us 2/4. And adding another fourth would give us 3/4. And adding another fourth would give us 4/4. What's 4/4? Yep, it's what I like to call a whole fraction, because its value equals 1 whole. Oh, and by the way, we're going to be using the term whole fraction a lot in this video. It's not an official math term, so your teacher might not use it. But just remember that whenever I say whole fraction, I'm talking about any fraction that has the exact same number on the top and on the bottom. 2 over 2, 8 over 8, 100 over 100, those are all what I call whole fractions. Since all whole fractions equal 1, you can replace any whole fraction with 1. And you can replace 1 with any whole fraction. And you can see how that works on our number line. The 4/4 all combine to cover the same distance as 1. The fraction 4 over 4 is equivalent to 1, and vice versa. But now, what if we get a little crazy and add one more fourth? Now we have 5/4, and we've gone past 1 on the number line. 5/4, or 5 over 4, is what we call an improper fraction, because the numerator, the top number, is greater than the denominator, the bottom number. That means its value is greater than 1. In this particular case, how much greater than 1 is it? Well, on the number line, we've gone past 1 by the fractional amount 1/4. So 5/4 turns out to be equivalent to 1 and 1/4. Have a good look at this diagram for a minute, because it shows us something really important about how proper fractions, improper fractions, whole fractions, and mixed numbers all relate to each other. First, on this side of the number line, we have 5/4, which we know is an improper fraction. But notice how we got it. We added a proper fraction to a whole fraction. When we just had 4/4, we had a whole fraction. But when we added one more fourth, it became the improper fraction 5 over 4. So one way to think of an improper fraction is that it's a combination of one or more whole fractions and a proper fraction. That's helpful because we know that all whole fractions can be simplified to the whole number 1. And if we did that, we'd get what's shown on the other side of the number line. We'd get the combination of the whole number 1 and the proper fraction 1/4. In other words, we'd get a mixed number. That's all a mixed number is. It's the sum of a whole number and a proper fraction. It's an alternate way to write an improper fraction where all the whole fractions that are inside the improper fraction have been simplified out into a whole number. To help that sink in, let's look at another improper fraction, 8 over 3, or 8/3. We'll use the same number line that goes from 0 to 3, but this time, let's subdivide each whole number into 3 parts to make counting thirds easier. So this would be 1/3, this is 2/3, and this is 3/3. Oh, there's a whole fraction already. Let's make note of that while we continue adding thirds. Next we have 4/3, 5/3, 6/3. Oh, we just formed another group of 3/3. That would equal a whole fraction also. Let's note that and continue. 7/3 and 8/3. As we noted, 8/3 actually contain 2 whole fractions. Each of those whole fractions simplifies to 1. So that means our mixed number form would have 1 plus 1, or 2, as the whole number part. And then the fraction that's left over after simplifying all the whole fractions is 2/3. So the improper fraction, 8/3, is equivalent to the mixed number 2 and 2/3. Pretty cool, huh? And to show you that you can go back and forth between these two forms, check this out. In the mixed number 2 and 2/3, the whole number 2 and the fraction 2/3 are being added together. That's really important to know, even though the plus sign isn't usually shown. So 2 and 2/3 is really 2 plus 2/3. And if we wanted to, we could expand the 2 into 1 plus 1, right? That gives us 1 plus 1 plus 2/3. And then we could replace each of those 1s with the whole fraction 3 over 3, since 3 over 3 equals 1. That gives us 3 over 3 plus 3 over 3 plus 2 over 3. Since these fractions all have the same denominator, we can add them easily. The denominator of the answer will stay the same, 3, and the numerator will be the sum of the other numerators. 3 plus 3 plus 2 equals 8. And there we are, back to our original improper fraction, 8 over 3. You can convert any mixed number into an improper fraction using that procedure. You can change the whole number part into a sum of whole fractions and then add everything up. For example, 2 and 1/8 could be changed into 8 over 8 plus 8 over 8 plus 1 over 8, which all add up to 17 over 8. And 3 and 4/5 could be changed to 5 over 5 plus 5 over 5 plus 5 over 5 plus 4 over 5, which all add up to 19 over 5. And 4 and 2/3 can be changed to 3 over 3 plus 3 over 3 plus 3 over 3 plus 3 over 3 plus 2 over 3, which all adds up to 14 over 3. Notice that we always chose whole fractions with the same denominator of the fraction part of the mixed number, so that they're all like fractions that can be added easily. And some of you might see the shortcut here. In each case, did you notice how many of the whole fractions we needed to add together? Yep, it's the same as the whole number part of the mixed number. If it's 2, then we need to add 2 whole fractions. If it's 3, we need to add 3 whole fractions. If it's 4, we need to add 4 whole fractions, and so on. The whole number tells us how many times to repeat the addition. And since multiplication is repeated addition, we can multiply instead of adding. 2 times 8 over 8 gives us 16 over 8, and then we add that result to 1 over 8 to get 17 over 8. 3 times 5 over 5 gives us 15 over 5, and then we add that result to 4 over 5 to get 19 over 5. 4 times 3 over 3 gives us 12 over 3, and then we add that result to 2 over 3 to get 14 over 3. That shortcut really helps when the whole number part of the mixed number is big. Like, what if we needed to convert the mixed number 15 and 1/4 into an improper fraction? Instead of having to add 15 whole fractions together, we can just multiply 15 by the whole fraction 4 over 4, which gives us 60 over 4. Then we add that result to the fraction 1 over 4 to get 61 over 4. That's the improper fraction form of 15 and 1/4. Alright then, but what if we need to go the other way? What if we start with an improper fraction and need to convert it into a mixed number? Well, whenever we have an improper fraction, we know there's at least one whole fraction hiding in there that we could simplify out. The question is, how many? To see what I mean, Let's try converting the improper fraction 7 over 2 into a mixed number using a little trial and error. First, let's try subtracting out just one whole fraction. 7 over 2 minus 2 over 2 equals 5 over 2. That means we can write 7 over 2 as the mixed number 1 and 5 over 2 since we subtracted out one whole fraction and had 5 over 2 left over. And even though that's true, it's bad form because 5 over 2 is still an improper fraction, which means that there's at least one more whole fraction hiding in there that we could have subtracted out. So let's try again, but this time let's subtract out two whole fractions. 7 over 2 minus 2 over 2 minus 2 over 2 equals 3 over 2. That means we could write 7 over 2 as the mixed number 2 and 3 over 2, since we subtracted out two whole fractions and had 3 over 2 left over. But that's still bad form, because the fraction part is still improper. We could have subtracted out another whole fraction. So let's try again, subtracting 3 whole fractions this time. 7 over 2 minus 2 over 2 minus 2 over 2 minus 2 over 2 equals 1/2. That means we could write 7 over 2 as the mixed number 3 and 1/2, since we subtracted out 3 whole fractions and had 1/2 left over. And that's the proper mixed number form of 7 over 2, because it's a whole number and a proper fraction, so there's no more whole fractions that we could simplify out. That process makes sense, but it's kind of messy having to subtract out so many whole fractions. It turns out there's a shortcut we can take here too. Just like multiplication is repeated addition, division is basically repeated subtraction. That means we can figure out how many whole fractions we can subtract out of an improper fraction by just dividing the top number by the bottom number. Let's do that with our example 7 over 2. If we divide 7 by 2, we find out that 2 will divide into 7 3 times, leaving a remainder of 1. That remainder is actually important, as we'll see in a minute. Notice that the answer to our division problem is exactly how many whole fractions we were able to subtract out of the improper fraction, 3. So the answer to the division tells us what the whole number part of the mixed number will be. And here's the really cool part. The remainder of the division tells us what the leftover fraction will be. The remainder is the numerator, the top number of the leftover fraction. In this case, since the remainder is 1, we'll have 1 over 2 left over in our mixed number. Let's do one more example to make sure you've got that. Let's convert 22 over 5 into a mixed number. If we divide 22 by 5, we see that 5 will go into 22 4 times with a remainder of 2. That means that the whole number part of the mixed number will be 4, and the fraction part will be 2 over 5, because our remainder was 2. That's how many fifths will be left over. So 22 over 5 is the same as 4 and 2/5. Alright, so now you know what mixed numbers are. They're a combination of a whole number and a proper fraction. And you know that those two parts are actually being added together, even though the plus sign is usually not shown. You also know that a mixed number is basically a simplified form of an improper fraction, and that you can use the procedures we learned to convert back and forth between the two forms. But the way to make sure that you really understand mixed numbers, improper fractions, and how to convert between them is to practice. You need to do some exercises on your own and check your answers to make sure you're doing the procedures right. Oh, I'm doing it right. In fact, I found an even quicker shortcut. How's that for mixed numbers? As always, thanks for watching Math Antics, and I'll see you next time.
All right, guys, that's going to be it for today. Enjoy your day and stay safe.